Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is your instructor Anisa Nawaz from Department of Physics. This is our lecture number 13 from chapter number 2, Vectors and Equilibrium. In the previous lecture we have discussed about resolution of vectors, components of a vector, magnitude of vectors by rectangular components, and determination of angle of vector. In this lecture we will discuss about addition of vectors by rectangular components. We will find the magnitude of resultant vector and we will find the direction of resultant vector by using the method of rectangular components. Okay, the topic addition of vectors by rectangular components is important in a sense that most of the times it is repeated in long questions. It is important from the point of view of section D in the question paper, which comprises of the long question. So you have to solve this question with proper headings. Okay. As we know that addition of scalars and scalars is done by the arithmetic means. Addition of scalar and scalar is very simple, just like we are adding the numbers 2 plus 3 is equal to 5, and just like that. This is known as arithmetic way of addition, but this addition cannot be done with the help for the vectors. Okay, vectors cannot be added by simple arithmetic means. We can use different methods for the addition of vectors. Addition of vectors may be done by geometrical or graphical method, which we have already discussed, head to tail rule, and second method is analytical method, which we will discuss now, addition of vectors by rectangular components. Keep this in mind that only scalars and scalars can be added, or vectors and vectors can be added. Scalars cannot be added to the vectors because these are two different physical quantities. If it is asked in MCQs, then you should know this thing that a scalar cannot be added in vectors. Okay, so we have already discussed about the rectangular components, and if we are going to do the addition of vectors by rectangular component, it is simply analytical method for addition of vectors is called addition of vectors by rectangular components. This method is more mathematical in nature, hence is more accurate, because we have discussed head to tail rule, in which we have calculated the resultant with the help of scale. That was not very accurate result. And we have already discussed about rectangular components of a vector, that if the components in which a vector is split are perpendicular to each other, such components are called rectangular components of a vector. Adding vectors graphically provides limited accuracy. Vector components provide a general method for adding vectors. We are having a proper formula and we are having a proper result after adding the vectors with the help of rectangular components. Okay, so we have discussed about head to tail rule, in which we have considered a proper scale, then we have drawn the coordinate axis, and then we have drawn the given vectors according to the scale and the given data. Then we have joined the tail of second vector with the head of first vector, and we have taken the appropriate scale as well, and in the end we have joined the tail of first vector with the head of last vector to get the resultant. We have calculated magnitude of resultant with scale, and we have calculated the angle with protractor to get the proper result. Okay, now if we are doing the vector addition with the help of rectangular components, then again we will consider the given vectors. A vector, let's say we are having a coordinate axis xy axis, and we are considering a plane vector, vector A, which is making an angle theta A with the positive x-axis in anti-clockwise direction. Keep this in mind that our required angle is always the angle which is made with the positive x-axis in the anti-clockwise direction. And we are having another vector, vector B, again making an angle of theta b with positive x-axis. And now we have to add these two vectors. If we are going to add these two vectors, what we have to do, we have to join the tail of vector b with the head of vector a. We have to join tail of vector b with the head of vector a without changing its direction and magnitude. Then by simple head to tail rule, we will draw a vector from the tail of first to the head of last vector. Okay, from the tail of first to the head of last vector. This is resultant vector of vector a and vector b, which are drawn to the scale. Then we know that rectangular components are those components which are perpendicular to each other, and to draw the rectangular components we have to resolve the vector by drawing its projection along x-axis and y-axis. So if we are dropping the perpendicular for vector b along y-axis and x-axis, and we are dropping a perpendicular for vector a along x-axis and y-axis, you can see that this is vertical component of vector b, this is horizontal component of vector b, vertical component of vector a, and horizontal component of vector a. Okay, so over here you can see that now we have resolved vector a into its vertical and horizontal component, and we have resolved vector b into its horizontal and vertical component. You can see that the arrowheads are pointing in such a way that when we will add these two vectors, we will again get the same resultant. Okay, when we will add these two vectors, we will get same resultant. Okay, now we have to find out the resultant vector. So we will move these vectors in such a way that we get the horizontal and vertical component of the resultant. You can see that all these vectors should be having proper arrowheads on these. Okay, so now if we are replacing this vector in such a way that you can see like this, we can replace these vectors. We are moving these vectors in such a way that horizontal components, when we are going to add the horizontal components, we will get a resultant Rx. You can see this resultant is having a horizontal component in this direction of this magnitude. You can see over here, this is the resultant horizontal component of resultant, and we can say that when we are going to add ax and bx, we will get Rx. You can see in this figure, when we are adding horizontal component of vector a and vector b, we will get horizontal component of resultant. In the similar way, when we are drawing vertical component of resultant, you can see this vertical component of resultant can be obtained by adding vertical component of vector a and vertical component of vector b. So in simple words, we can say that when we are going to add all the horizontal components of given vectors, we will get horizontal component of resultant, and when we are going to add all the vertical components of given vectors, we will get vertical component of the resultant. Now if we are going to do the mathematical calculation of this figure, how we are going to do that? We will first find out the magnitude of horizontal component by head to tail rule. We know that R vector is equal to vector a plus vector b. We have done this. We have added vector a and vector b to get the resultant. From the figure, we have Rx is equal to ax plus bx. We have discussed this thing that when we are going to add all the horizontal components, we will get the horizontal component of resultant. If we are writing this vector in this way, magnitude and its direction, you know that if we are talking about x direction, then we have to use unit vector I hat. So we can write this vector Rx in this form, Rx I hat. Vector Ax can be written as Ax I hat, and vector Bx can be written as Bx I hat. Now if we are just considering the magnitude without direction, then we can write it as magnitude of Rx is equal to magnitude of Ax plus Bx. Name it as equation number 2. This was just for two vectors, vector A and vector B. We can do the same calculation for a number of vectors. If we are having more than 2 vectors, then how we are going to write this resultant? Rx is equal to Ax plus Bx plus Cx plus Dx up to so on. We will add all the x components of the given vectors, and you know that how we are going to find out the resultant vector. If we know the angle and the given vector, we can find out horizontal component by using formula. A is equal to A cos theta, B is equal to B cos theta, C is equal to C cos theta, and up to so on. We can find out the horizontal components. After that, we will add all those horizontal components to get the horizontal component of resultant. If we are going to find out the magnitude of vertical component of the resultant vector, then how we are going to do that? Again, from the figure we know that Ry is equal to Ay plus By. If we are going to add the vertical components of the given vectors, we will get vertical component of the resultant. If we are going to write this Ry in this way with unit vector, then you know that we can write j hat along y direction. So Ry vector will be written as Ry j hat, Ay vector is equal to Ay j hat, and By vector is equal to By j hat. So just using the magnitude, we can write it as magnitude of Ry is equal to magnitude of Ay plus By. Name it as equation 3. Equation 2 was for Rx, equation 3 is for Ry. And again, if we are having more than 2 vectors which we are going to add, then Ry will become Ry is equal to Ay plus By plus Cy up to so on. So we have calculated the magnitude of horizontal component, we have calculated the magnitude of vertical component. Now we will calculate the resultant vector. By rectangular components, we know that vector r is equal to rxi plus ryj. We know that if we are going to add its horizontal and vertical component, we will get resultant again. Okay, r is equal to rxi plus ryj. We have done this in resolution of factors. So if we are going to put the values for resultant vector, we know that Rx is equal to Ax plus Bx, equation number 2, and from equation number 3 Ry is equal to Ay plus By, and equation number 4 was vector r is equal to Rxi plus Ryj. We will put the values of Rx and Ry in equation number 4. From equation number 2 and 3 we will get a vector r is equal to Ax plus Bx I hat plus Ay plus By j hat. So this Ax plus Bx in place of Rx and Ay plus By in place of Ry. We will get this equation, vector r is equal to Ax plus Bx into I hat plus Ay plus By j hat. Name it as equation number 5. Again, it is for 2 vectors. If we are having more than 2 vectors, then resultant will become Ax plus Bx plus Cx plus Dx up to so on into I hat plus sum of all the vertical components into j hat. So this basically is the x component of resultant, and this is y component of the resultant. Okay, in this way we can find out the resultant vector. We are going to find out the resultant vector. R is equal to sum of all the x components into I hat plus sum of all the y components into j hat. Okay, so if we are going to find out the magnitude of resultant vector, we have already done the formula of magnitude. That was magnitude of any vector is equal to under root square of its x component plus square of its y component. So over here, if we are having the resultant r, magnitude of resultant is equal to under root rx square plus ry square. Square of x component plus square of y component whole under root is equal to r. We have calculated this formula with the help of Pythagoras theorem while we were doing the resolution of vector, and again same, we are using the method of rectangular components, so we can apply Pythagoras theorem to derive this formula. We already know this formula, so we will just put it directly over here. So by putting the values of Rx and Ry from equation 2 and 3 in equation 6, we will get magnitude of resultant is equal to whole under root ax plus bx whole square, we are just putting value of rx over here, plus ay plus by whole square, we are just putting value of ry over here. Okay, name it as equation number 7. And if we are having more than 2 vectors, then magnitude becomes magnitude of r is equal to under root sum of all the x components whole square plus sum of all the y components whole square. So this will be the magnitude of resultant vector, which we are going to calculate mathematically. In head to tail rule, we have calculated the magnitude of resultant with the scale, but right now we are going to calculate the magnitude of resultant with this proper formula, and we will get a proper value, accurate value. Okay, so if we are now going to calculate the direction of resultant vector, again we have done by rectangular component, we have done with the formula theta is equal to tan inverse of y component divided by x component. Over here we are talking about direction of resultant, so we will write it as ry divided by rx. Theta is equal to tan inverse of ry by rx. Okay, if you are going to put values of rx and ry from equation 2 and 3, we will get theta is equal to tan inverse of ay plus by divided by ax plus bx. We have calculated the angle. Okay, and if we are having more than 2 vectors, then we will simply replace ry with sum of all the y components and rx with sum of all the x components. This is basically the equation number 9. Okay, so we are having theta is equal to tan inverse of ay plus by plus cy up to so on divided by ax plus bx plus up to so on. Okay, in this way we can find out the direction of resultant vector. Okay, so if we are going to check out the steps for vector addition by rectangular components, if you remember these steps, then it will be very easy for you people to write down the long question, as well as it will be easy for you people to solve the numerical problems. You just have to follow these steps. That first, draw the individual vectors to be added. You have to draw the individual vectors according to the scale. Then find the x components and y components of all the given vectors. Okay, given vectors are there, you have to find all the x components by using formula f cos theta or a cos theta, whatever the vector is, and y component by f sin theta or a sin theta, whatever the given vector is. Okay, you have to draw the individual vectors, then find x and y components, then add x components of all the given vectors to get x component rx of the resultant, then add y components of all the given vectors to get y component ry of the resultant vector. Find the magnitude of resultant by formula r is equal to under root rx square plus ry square, and find the direction of resultant vector r by theta is equal to tan inverse of ry by rx. Okay, so what you have to do, draw the individual vectors, find all the x components, find all the y components, add all the x components, add all the y components, find magnitude by using formula, and find direction by using this formula. But this last point, find the direction of resultant vector by theta is equal to tan inverse of r by rx. This theta is, this could lie in any quadrant, but we have discussed this thing that our required theta must be from positive x-axis in anti-clockwise direction. Okay, so there will be a difference in the calculation of theta r angle for the resultant. How we are going to calculate that? Let theta be the angle made by the vector r in any quadrant. This theta which we are going to calculate, this theta will be lying in any quadrant, first, second, third or fourth, and theta r be the angle made by a resultant vector with positive x-axis in anti-clockwise direction. The angle which we are going to calculate for resultant is the angle with positive x-axis in anti-clockwise direction. Then what we will do, we will determine angle theta irrespective of the positive and negative signs of rx and ry, as theta is equal to tan inverse of ry by rx. While we are going to find the magnitude of rx and ry, this magnitude could be negative or positive. Okay, we are just adding all the magnitudes of the individual components. Okay, so this sine theta and cos theta, they can give us positive value or negative value. Okay, so if we are going to find out this ry and rx individually, they could either be positive or negative, but while calculating theta, we will not put positive or negative sign in this formula. We will just put their magnitude irrespective of their signs, and we will calculate theta. What about the sign? We will find it out. What is the significance of positive and negative sign over here? We know that we are having 4 quadrants: first, second, third and fourth. This is first quadrant, second quadrant, third quadrant and fourth quadrant. Okay, so we have already discussed this thing in detail, that in first quadrant x axis is positive, y is positive. In second quadrant x is negative, y is positive. In third quadrant both and x and y are negative, and in fourth quadrant x is positive and y is negative. Okay, so if we are calculating the value of rx and ry, and we find it out that rx is positive and ry is positive, then we know that angle of resultant lies in the first quadrant. Okay, we will draw our resultant vector in the first quadrant. This resultant is making an angle theta. Now what about theta r, angle made by the resultant? You can see here that same theta is the angle made from positive x-axis in the anti-clockwise direction. So we can say that theta r is equal to theta. There is no change in theta r, or we can simply write it as theta r is equal to theta. So there will be no change in the calculation if both rx and ry gives us the positive result. But what if we are having such a result that in which we are having rx is negative and ry is positive? We know that this condition is for second quadrant, rx negative and ry positive. So if rx is negative and ry is positive, then theta r lies in the second quadrant. Okay, this is our resultant vector, which is making an angle theta with the x-axis of the second quadrant. But this is not our required theta. This is not our required angle, because according to definition we have discussed this thing, that our required theta is from positive x-axis in the anti-clockwise direction. So this is basically our required angle theta r. Now we have to calculate the value of this theta r. This theta r is equal to, over here you can see that this theta r can be calculated by subtracting this theta from this whole angle. We can subtract theta from 180 degrees to get this theta r. Okay, so if we are having such a value in which rx is negative and ry is positive, then first we will put these values in the formula theta is equal to tan inverse of ry by rx, both with positive signs. Okay, we will not put negative sign in that formula. We will calculate this value of theta, we will draw vector, resultant vector in this direction, and then we will calculate theta r by subtracting theta from 180 degrees. So we can say that theta r is equal to 180 degrees minus theta. We will subtract theta from 180 degrees to get this value of theta r. And if we are having such a condition in which we are having rx as negative and ry as negative, so this is the condition for third quadrant. Theta r lies in the third quadrant. We will draw our resultant in the third quadrant with angle with x-axis of the third quadrant. Okay, but this is not our required angle. Our required angle is starting from positive x-axis and in the anti-clockwise direction. So this theta r is basically our required angle. Okay, so how we are going to calculate this theta r? We will add 180 degrees with theta. Okay, we will add 180 degrees with this angle theta. Sometimes students make a mistake over here that they put the angle from this y-axis over here. They are naming this angle as theta, which is incorrect. Theta is always with x-axis, so we will consider this as theta, and net angle theta r is 180 degrees plus theta. Okay, so we can write theta r is equal to 180 degrees plus theta. And if we are having such a condition in which we are having the value of rx as positive and value of ri as negative, so this is the condition of fourth quadrant. We will draw our resultant in fourth quadrant. Okay, and this will be our theta, which is not our required angle. Our required angle is starting from positive x-axis moving in the anti-clockwise direction. So this is our required angle theta r, and we can say that theta r is equal to this whole circle minus this angle. Okay, so we can write it as 360 degrees minus theta. We know that in complete circle we are having 360 degrees, so this theta r can be calculated as 360 degrees minus theta. Okay, so we can write the formula as theta r is equal to 360 degrees minus theta. In this way we can find out the angle for the resultant vector. Okay, so in this lecture what we have done, first we will draw the diagram. If we are going to do the long question, then we can make these points as headings. We will draw the diagram, then we will give the explanation. In explanation we will explain all the things which we have done while drawing the diagram, that consider vector a, b and all those things. Then x component of the resultant, y component of resultant, resultant vector, magnitude of resultant vector, direction of resultant vector, and determination of angle theta r. All these could be the possible headings. You can increase the number of headings for the long question. Okay, so in the next lecture inshallah we will discuss about the assignments, assignment 2.1, example 2.2, 2.3 and assignment 2.2 and 2.3. Okay, so for today's lecture that was all. I would like to end my lecture with this quote, that the greatest enemy of knowledge is not ignorance, it is the illusion of knowledge. Okay, ignorance is not the greatest enemy of knowledge. It is basically the thinking that I am perfect, I have all the knowledge. This thinking is basically the enemy of the knowledge. Our journey to seek the knowledge is never ending. Okay, from cradle till the grave we have to seek the knowledge. We can never be perfect, so ask question, gain knowledge, that will be better for you. Best of luck to all of you. Thank you so much. That was all for